start by going over the drawing that I have up on the board, and then we're going to get into double bond and triple bond today. Because the good news is, for the most part, that doesn't affect a lot of what we have to go through. Okay, so what you were supposed to figure out from last class is carbon chains are a very common thing. And then what comes off of those carbon chains gives them their identity. So the organic chemistry that we briefly touch upon is learning how to name some of these carbon chains. What you would need to do, if you look at a picture like this, is first determine what is the longest carbon chain. So typically you're going left to right or right to left. I mean, it could be top, bottom, bottom, top. But I see 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons. Because in line angle format, at the end of every line is a carbon. And every time two lines meet, an angle is a carbon. So that's why I count 9 carbons on that longest chain to begin with. Hydrogens are assumed to get things to the octet. And one of the things I was hoping that the first round of notes were going to show you was that this is the much preferred way of drawing out some of these organic molecules, because it just takes a long time to draw out those hydrogens, even if you actually draw the H bonds, or even if you just call it CH3 bonded to CH2 beyond the CH, but then there's a Cl on it as well. It takes a long time. And that's why line angle format is used for organic molecules. If I were to name this, that means I already know a 9 carbon chain is going to be called a non-ane. Non is the prefix for 9. Ane, because it's an alkane. It's all single bonded. Once you've identified the longest chain, you look to see what remains. For example, I have a chlorine right here. That's something coming off of that side chain. This is a 1 carbon group on carbon number 4. That is a methyl group. This carbon right here has a methyl group coming off of it as well. But if you look at what I currently have numbered as carbon number 5, there are 2 carbons coming off of it. One right here, and then one right here. So that is an ethyl group. Eth is the prefix for 2. So, naming of organic commonly works backwards, which is why you kind of have to give yourself space as you go along. I know that it ends in nonane. It's a 9 carbon chain. But now I need to identify all the other groups. I have a chloro, I have 2 different methyls, and I have an ethyl. And the rule we have to abide by is alphabetical order. In other words, when I start my naming in the front, chloro is going to have to be first in here, because C comes first in the alphabet. So I'll put pen and blue, let's say. Ethyl comes next. And, darn. I have 2 methyl groups total. So I have to indicate that by calling it dimethyl. And then I'll have my nonane at the end again. Now again, the one I'm giving you is not a very basic one. So if we are one of those people that are more thumbs down, again, let's go back and look at what we did last time. That's what hopefully work time can accomplish here.
Can you go over to a little bit, like in our last class there were some that had like, there would be like 2 and then like 2 columns.
Yeah, and we're actually not done with this one yet because we're going to get into that here. So what Claire's asking about is next. Now that we've identified the different groups and how many of them, dimethyl, we have to give the location of these as well. And that's where we have to use the numbers from the carbon chain. However, maybe I shouldn't have given this one right away. This is a little bit trickier. The numbering system is based upon not necessarily reading left to right. I know even your reading guide had one problem from the book that was trying to do that to you. We have to number left to right, right to left, however it is, so that it's the lowest number for each subgroup. And what I mean by that is if I named it right now, I'd call it 3-chloral, 5-ethyl, 4,8-dimethyl. But if I instead numbered 1, 2, 3, 4, 5, 6, 7, 8, and 9, I now have a subgroup in carbon 2. That's a lower number. That's the direction we have to go. So again, I am trying to actually summarize everything from last class period. That last thing that I just did, that's what commonly students have a hard time with. Because now, my chloral group is on carbon 7. My ethyl group, hey, it's still on carbon 5. And then it's 2, 6. So the name of that compound would be 7-chloral, 5-ethyl, 2,6-dimethyl-nonate. At the end of last class, again, looking at it right now, the worksheet I had, I drew out AP Chem and you were supposed to write it. I think this one is a little simpler than what I just drew up on the board. Heck, my H is pretty straightforward. My M is just a carbon chain with nothing else coming off of it. That was just pentane. So what I asked the sub to do, and again, I don't know how far we got, was to have you guys draw out something kind of letter form and then try to name it or have someone else name it at that point. The reason why we did that is to lead you into what the extra credit that we give for organic is going to be about. Typically what I do is, it could be a drawing, but usually students just like to do letters. I give them parameters, like at some point you have to include a methyl group on one of the things. At some point you have to include an ethyl group, or maybe a halogen. And like today we're going to go over something with a double bond, something with a triple bond. But otherwise, I kind of give freedom for students to create their own problem and their own answer. So if this one was a little complicated, well, maybe you won't create something quite that complicated. I wanted to simply give a problem that encompassed everything that was supposed to be on the reading guide and notes last time. If you are still concerned, hopefully the notes that we do today, which is the last time I'm doing notes with you guys, hopefully that will make a difference with some of this as well, because all we're doing is adding one last step to what we're doing. Okay? So again, if we're a little shaky still, let's get through the notes. You picked up on the way in a worksheet that just has practice problems on it. You'll get to work on that for a little bit. Maybe you're someone who would want to work on last time stuff. Maybe at the end of class today, and I have to check with third hour, if overall we're feeling a little shaky on it still, maybe we don't have to do the extra credit on Friday. Maybe we push that off until Tuesday instead, or Wednesday, I guess is when I'd see. Part of me wants to just say, hey, let's get everything done this week, and then let's really coast this last week afterwards. However, we want to make us have fun with what we are doing here and get hopefully a couple points back. So if we feel like we need a little extra time, then we'll do that. But at the same time, everyone's going to be doing it on the same day. We're not going to have kind of a half-half thing. So what I'm going to go over then are alkenes that are double bond involved in that carbon chain, and an alkyne that has a triple bond. Now I mentioned on here a little bit about rings. I believe that was covered actually last class. So hopefully we don't have to actually go over the rings part again. Okay. Again, I don't know if you have to actually jot down these notes. When dealing with something with a double bond, we first identify the longest carbon chain, just like we would with single bond stuff. Now, our number system is based upon the double bond having the lowest number, not like a methyl group or an ethyl group or anything like that. It's the double bond that would give it its lowest number. One of the most common mistakes students make is they count left to right all the time. And I get it. That's the easy way to do it. But sometimes you have to actually number right to left or top to bottom, especially if you're starting to draw kind of goofy things. Otherwise, all those subgroups, or what we might call functional groups, it's the same rules as before. There is one last thing for me to know. There are some carbon chains that have more than one double bond. On the problem I just showed you, you had two methyl groups. So what did we do? We called it dimethyl. Well, if there's two double bonds, we call it diene instead. Again, I might give you practice problems with that, but realize once again, what you will be assessed on is something that you are creating. Will I ask you to do that? Perhaps. But there's also a very good chance that I will just say at some point you have to have a double bond in something. Okay, so those are our rules. Again, to me, it makes sense to just start going over practice problems. I can give you a minute to see if you can figure this out, or I can just immediately start talking and going over how to solve this. What would we like? Give you a minute? Okay. If nothing else, if you are still unsure, you should be able to figure out the longest carbon chain. Hopefully you can figure out where that double bond is. And perhaps formatting of how you write your answer you'll be a little confused with because I didn't give you a sample problem first. So what I'll do is I'll show you the answers here in a minute. And then we'll go back to this slide and I'll kind of talk you through it. We're going to reveal this in about 15 seconds. And then I'll go back and I'll show you how we solve it. The first one was 3-methyl 3-hexene. What that means is there was a methyl group on the third carbon. That's why it's 3-methyl. there was a double bond on the third carbon, 3-hexene, and it was a 6-carbon chain, is where the hex comes from. If that is, unless we got rid of the methyl group, as straightforward of a double bond scenario we could give you. Now the second one had 2 double bonds, a little bit trickier. First off, 7-ethyl, because on the 7th carbon was a 2-carbon group, an ethyl group, C2H5. Then, it was a 9-carbon chain, that's why I have nana, but there was 2 double bonds. So it's not a non-ene, it's a nana-diene. I then give the location of both double bonds, the 2nd carbon and the 5th carbon. So if I go back to that again, 1, 2, 3, 4, 5, 6, and I see a double bond, that tells me it's going to be a 3-hexene. The naming typically works kind of back to the front. Then I also have a methyl group on that 3rd carbon, so 3-methyl 3-hexene. On the bottom one, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is non, but there's 2 double bonds, so I'd call it a nana-diene. Where are those two double bonds? One's on the 2nd, one's on the 5th. So 2,5 nana-diene. Then what haven't I covered yet? This 2-carbon group on the bottom off the 7th carbon. That's where the 7-ethyl comes from. Okay. Now, we do have to tweak this a little bit. And that is going over something called cis and trans isomers. I'm going to give you an example here for 1,2-dichloroethene. And I'm actually going to draw it out not in line angle, I'm going to draw it out in normal fashion. That could be 1,2-dichloroethene. Notice that we're not saying 1-ethene. You don't have to label what carbon the double bond is coming off of. If it's a 2-carbon chain, it has to be starting at the 1st carbon. But wait, there's a second way I could actually draw this. An isomer, which was a term brought up last class, is the same formula with a different structure. These have the exact same formula, however, they have a different structure. And this particular example has been brought up on past AP exams. Maybe it was even on a practice test at some point that you did. And it's not brought up anything to deal with organic naming. It's brought up with the fact that one of these two is a polar molecule. The other is a non-polar molecule. Which one is polar? The one on the left or the one on the right? Left. With both chlorines going in this direction, there is a net dipole moment in one direction, making it polar. On the second example, with the chlorines going opposite of one another, those net dipoles cancel each other out, and it's a nonpolar molecule. That's where I've seen this brought up before. And actually, I'm going to show you an example next class of how an isomer switching between these two versions is the basis for eyesight. Dealing with, I believe it's the rhodopsin molecule. Because these two have the exact same formula, the double bonds are in the same location, the functional groups are in the same spot, and yet they're not the same, there has to be a way to differentiate between the two. And that's what the prefixes of cis and trans are meant to do. And what I mean by that is on this first example on the left, both chlorines are going in the same direction off that double bond. We okay with that statement? They're both going up? Same means cis. In the second example, the chlorines are going in opposite directions. This is trans. So one of the things that we need to do is differentiate between these two if it's coming off, if we have two groups coming off that double bond on opposite ends of it. Okay, these are the problems that we did a minute ago. So we're not having to redo it. We're going to add one last thing to it. We have to label the double bond as either cis or trans. Now in line angle format, it might seem weird, but trust me, you're going to like this instead. We have two carbons that we have to look at here. This one and this one. Again, both ends of the double bond. There are two different things coming off of this carbon number 3. Now, especially if you kind of tilt your head, one part's going up, one part's going down. I would say the bigger of the two things is this part. Right? Two carbons here, only one carbon there. On the second carbon here, carbon number 4, there's nothing going up, so that's an assumed hydrogen. So the bigger group is going down. In other words, they're going in opposite directions. Which is why that first one would be called 3-methyl trans 3-hexene. Then, I do the same thing with my bottom one. Again, if I look at carbon number 2, it looks like I have something going down and something going up. That must be trans right there. If I look at carbon number 5, I see something going up, something going down. That must be trans as well. Quite frankly, ladies and gentlemen, when you draw zigzags, it's going to be trans. Unless you started drawing things like this, and then having zigzags coming off it or whatever. Because then that would be cis. That's why that second one is trans as well. And again, we'd have to label both of them. Trans, 2,5.